In this video, we are going to learn everything about hydraulic directional control valve. Not just what they are, but how to select the right valve. And more importantly, how to use them in real hydraulic circuits. Because knowing the symbol or understanding the hydraulic circuit just by looking at is one thing. But designing a working hydraulic circuit from scratch is completely different challenge. Because hydraulic circuit design is not only about the logic, it's more about understanding how system behaves in practical condition. And this is where most mechanical engineers struggle because there is no single hydraulic circuit that works for every machine. Every system is different. Some use variable displacement pump, others use fixed displacement pumps. Some hydraulic cylinders mounted vertically, some are mounted horizontal. In some cases, you need to hold a heavy load safely, and in others, the cylinder must be float freely. And on top of that, hydraulic cylinders works on very high pressure. So if circuit is not designed properly, you can face tons of problem like pump overloading, pressure shocks, or even oil leakage and component failure. So the real question is not just will this circuit work? The real question is will this circuit work safely, reliably, and efficiently in a real hydraulic machine? And this is exactly what we are going to learn in this video. First, we will build a strong foundation of directional control valves and their type. And then we will move to practical hydraulic circuit design, something that took me years of experience to understand, like how to hold a heavy vertical load without creep, how to unload the pump properly, and how to make the system stable and safe to operate. So by the end of this video, you will not only understand the hydraulic circuits, but you will be able to start designing them with your full confidence. This video is sponsored by Brilliant. More about them towards the end of the show. So let's start with very basic. What is a hydraulic directional control valve? So let's assume we have a double-acting hydraulic cylinder. And to operate this cylinder, we already have a hydraulic power unit with all necessary components such as the pump, an electrical motor, a pressure relief valve, and the oil reservoir. These all components work together to provide flow of hydraulic oil in circuit. But let's assume we don't have any directional control valve in this circuit. Maybe it's not invented yet. So how could we possibly operate this hydraulic cylinder without a directional control valve? Well, to extend the cylinder rod, we can connect the pressure line port of the hydraulic power unit directly to the rear port A of the cylinder. Now the hydraulic oil enter in port A and start pushing the piston forward. So the cylinder extends. Now once the cylinder is fully extended, to reverse the motion, we disconnect the power line from port A and connect it to the front port B of the cylinder. Now the oil supplied through the port B, but here is a problem. The oil already present on other side of piston must leave the cylinder. If there is no proper return path, the oil will simply start leaking. So we can connect that port back to the tank. So the cylinder retracts without any issue. Now once the cylinder is fully retracted, to extend it again, we again need to change both the pressure and tank connection, like this. Now, on paper, it looks simple and logical. But can we really do this in actual machine? Disconnecting and reconnecting the hydraulic hoses manually from one port of cylinder to other port of cylinder for every stroke of the cylinder? No, of course no. So to automate this process of switching of oil flow from one port to another and returning oil from opposite ports, we use a hydraulic directional control valve. A directional control valve for a double-acting cylinder typically has 4 ports: pressure port P, tank port T, cylinder port A, cylinder port B. Now, instead of moving hoses, we connect all these hoses permanently to the valve. Now, inside the valve, there is an internal spool. This spool moves inside the valve body and changes how the ports are connected internally. For example, in one position of a spool, the valve connects P to A and at same time B to T. So oil flow from pump goes into cylinder rear port and oil from cylinder front port goes back into the tank. So the cylinder extends. Now when a spool moves to another position, the internal connections change. Now the valve connects P to B and A to T. So the cylinder retracts. And this is why it is called a directional control valve, because it simply controls the direction of fluid flow inside the hydraulic system. Now, this particular directional control valve is called a 4x2 directional control valve. The first number represents the number of service ports in the valve. There are 4, P, T, A and B. And the second number represents the number of spool positions. So this valve has 2 positions, one for extending the cylinder and one for retracting the cylinder. Now, directional control valves can also have more than 2 positions. For example, 4x3 center closed double solenoid spring-centered directional control valve. This valve has 3 positions. The middle position is called neutral position. In this closed center valve, all ports are blocked in neutral position, so no oil flow through the valve. So a directional control valve not only controls the direction of flow, but it can also start and stop the flow. Now, this double solenoid spring-centered is actuation method of this valve. That means the spool shifts their right and left position using electrical signal on solenoid. And when none of solenoids are activated, the spring force pushes the spool and keep it in neutral position. Now, the valve actuation can be done in other way also. For example, it can be manual using lever or knob. It can be pneumatic operated, or it can be pallet operated using hydraulic pressure. Now, the ports of directional control valves can be connected in many different ways. And by combining different port configuration and different spool positions, we can theoretically create more than 200 types of directional control valves. But in practical industrial application, only a 5 type of directional control valves cover almost all the applications. Let's start with most basic directional control valve, 4x3 closed center directional control valve. And let's consider its solenoid operated with spring centering, which is mostly used in automated machine. So when we activate the right side solenoid, valves connect P to A and B to T. So cylinder extends. Now, when we activate the left side solenoid, connection changes to P to B and A to T. So the cylinder retracts. But when none of solenoids are activated, or if there is electrical power failure, then springs from the both sides pushes the spool and keep it in neutral position. In neutral position, all the ports are blocked, so no oil can flow through the valve. As a result, the cylinder stopped immediately and held the cylinder at that position. So we use this valve in application where we need to operate a double acting cylinder back and forth and also stop the cylinder at any position and hold it there. Now, there is something that we must understand. When this valve stays at neutral position, the pressure port P also gets blocked suddenly, but the pump is still supplying oil. So the system pressure quickly rises, and when it reaches the relief valve setting, the relief valve opens and pump flow is diverted back to the tank. So the system pressure maintained at relief pressure. That means every time we stop the cylinder, the pump is forced to operate at maximum system pressure. And if we keep the cylinder stopped for a longer time, mainly when machine is in rest between the operation, we must need to hold the cylinder at the top. But the pump continue running under high pressure, which leads to higher energy consumption, more heat generation and unnecessary load on pump. So why not we design the valve spool in such a way that in neutral position it only blocks the cylinder ports A and B and connect the pressure port P directly to the tank port T. Now since the cylinder ports are blocked, the cylinder movement will stop immediately and it will hold its position. And at the same time, because the pump flow is going directly back to the tank, the system pressure will not rise. So the pump is now unloaded, which means low energy consumption, less heat generation, and oil simply keeps circulating from pump to tank. This type of valve is called 4x3 tandem center directional control valve, also commonly refers as open center P2T. When I first understood this valve, I had a very simple question. If this valve can stop and hold the cylinder position and at the same time also unload the pump, then why do we still use 4x3 center closed valve? Why didn't this valve completely replace them? So here is a practical reason behind this. Let's say we have a hydraulic machine with multiple cylinders and they need to operate at different timing. So each cylinder has to controlled by its own independent individual directional control valves. Now imagine if one of those valves get into neutral position where P is connected to T in tandem center valve. So the entire system pressure drops immediately because the pump flow is going directly back to the tank through one of the valves. As a result, another directional control valves will not be able to operate properly. But in this case, if we use 4x3 closed center valves, even when one valve goes to neutral, the pressure line remains pressurized for all other directional control valves, so they can continue to operate. And that's the main advantage of closed center directional control valve over tandem center directional control valve. So as a general guideline, a 4x3 tandem center valve is best when system has a single actuator and we want to reduce the energy consumption while holding its position. But if the machine has multiple actuators which need to operate at different timing, then 4x3 closed center valve is the choice. Now in some application, especially in horizontal mounted cylinder applications, we need the cylinder to float freely so that it can move manually. This may be a functional requirement or machine maintenance or a safety reason. So in such situation, we use a 4x3 float center directional control valve. In this valve, at neutral position, both cylinder ports A and B are connected to the tank port T. So oil from the both side of cylinder can freely return to the tank. So there is no pressure left holding the piston. So the cylinder is in floating condition. But at the same time, the pressure port P is blocked. So as a result, the system pressure rises until relief valve open and the system maintained the relief pressure, which again leads to high energy consumption and increased heat generation. And to overcome this exact problem, there is another valve, the 4x3 open center directional control valve. In this valve, at neutral position, all the ports are connected. Now, because port A and B are connected to the tank, the cylinder goes in floating condition. It can move freely. And at the same time, because P is also connected to T, the pump flow goes back to the tank. So the pressure in system do not build up. So the pump is unloaded and energy consumption is reduced. But again, there is a limitation. The same limitation Tandem center had. That is, since the pressure port is connected to the tank in neutral position, the entire system pressure drops. So if the system has multiple cylinders and one valve goes in neutral, the pressure supply for the other actuators may not be available. So in such cases, for floating cylinder, float center valve is the choice. Now, apart from these 4x3 closed and float valves, there is a special valve called regenerative valve, also known as P to A and B. This valve is mainly used for fast approach of a cylinder. In this valve, at neutral position, the pressure port P is connected to both cylinder ports A and B, while the tank port T is blocked. Now, at first, this may look confusing. That is, if pressure is applied to the both side of the cylinder, then how can cylinder move at all? Let's understand this step by step. Let's assume the hydraulic pump supplying oil at 50 rpm. So when the valve is in working position, the cylinder receiving 50 rpm and it's moving at normal speed. But now when we shift the valve to neutral position, the same 50 rpm is supplied, but now it is going to the both ports A and B. Now here is the important concept. The pressure on both sides of the piston is almost the same, but the effective area are different. On the piston side, pressure acts on full piston area, but on rod side, pressure acts only on the annular area because the part of area is occupied by the rod. So the force on piston side is always greater than force on the rod side. So even though oil is supplied on both sides, there is a net force that pushes the cylinder to extend. Now, as the piston moves forward, the oil from the rod side must leave the cylinder, but the tank port T is blocked. So the oil cannot go back to the tank. So the oil coming from the port B is redirected to the cylinder port A. So now the cylinder port A is receiving pump flow 50 rpm plus the returning flow from the port B. So the total flow entering in piston side becomes much higher than the pump flow. So the cylinder moves much faster. This is called regenerative flow. And that's the main advantage of this valve is high speed during the approach stroke. But there is also a disadvantage. Because the pressure is acting on both sides of the piston, the net force is reduced. So the regenerative circuits are used only where we need high speed, but higher force is not required. So this was all about most used hydraulic directional control valves and their logical function. And now it's time to move from theories to something practical. So first off, all the directional control valves we discussed so far are spool valves. In a spool valves, a cylindrical spool slide inside the precise machine bore. When the spool shifts, it's open and close internal passage, and that's how it's making and breaking the connection between the ports. Now, the spool valves require a small clearance between the spool and the housing, typically 5 to 25 microns. This clearance is necessary to allow a smooth movement without the sticking and to ensure the proper lubrication of sliding surfaces. But because of this clearance, there is always an internal leakage between the parts. And this leakage depends on size of clearance, the fluid viscosity, and the system pressure. So as pressure increases, the internal leakage also increases. So in low pressure application, this may not be a problem. But in higher pressure machines, such as hydraulic presses or scissor lift, this valve's leakage becomes critical Because in these machines, the cylinder carries a heavy vertical load. And to stop and hold the cylinder, if we use a spool valve, like closed-centered or tandem-center valves, because of the internal leakage in these spool valves, over the time the cylinder creep and the load may start falling downward, which can lead to serious safety issue. Now, this doesn't mean the spool valves are useless. They work perfectly fine if a small creep is acceptable, or also if we don't have to hold the load for longer time, or if the load is not happy. But in application like heavy vertical press or where precision load holding is required, a spool valve alone is not sufficient. So in such case, which valve we should use? Is there any valve which does not leak? So yes, and that is Poppet valve. A Poppet valve, also known as seat valve, use a seat type sealing mechanism. A poppet pressed against a seat, creating a very tight seal with minimal leakage. Also, they can typically handle higher pressure than a spool valve. But poppet valves have their own limitation. In poppet-based design, each flow path requires separate sealing element. So creating a full 4x3 directional control valve using poppet mechanism becomes complex, more expensive and hard to manufacture. That's why poppet valves are mostly used in simpler configuration, such as 2x2 shut-off valve or 3x2 valve, and in check valve. On other hand, a spool valve uses a single sliding element, which make it easy to achieve almost all directional control configuration in compact and economical design. And that's why spool valves are widely used. But again, they comes with inherent internal leakage. So if poppet valves are complex and expensive, on other hand, spool valves have internal leakage. So what is the practical solution? So the most effective solution is use a spool directional control valves combined with pallet operated check valve. So what is pallet operated check valve? Before that, let's understand check valve. So a check valve is a one directional valve. It's allow the flow in one direction and block the flow in opposite direction. In hydraulic systems, check valves typically use a poppet as a sealing element, and the poppet is held against its seat using a spring. Now, when the inlet pressure exceeds the spring force, called cracking pressure, the poppet lifts and flow becomes possible in that direction. But when flow tries to come from opposite direction, it pushes the poppet more tightly against the seat, which ensure a very tight leak-free seal. So the flow is completely blocked. And this is how a simple check valve works. Now, before we understand a pallet operated check valve, we need to understand what pallet operated means. So, all types of hydraulic directional control valves can be classified on the basis of how their internal element, either a spool or poppet, are moved. First is direct operated. When the valve size are relatively small, the control element are moved directly by a solenoid or manual lever. But as the valve size increases, the force required to move the spool also increases significantly. And solenoid force cannot move heavy spool. So in large size valve, we use pallet method. A pallet operated valve consists of two parts, a small pallet valve and a large main valve. The pallet valve can be mounted with the main valve or it can be used remotely. Now, when the pallet valve is actuated directly by solenoid, it's direct a hydraulic pressure, typically 5 to 10 bar, to the main valve chamber. That pressure moves the main spool or poppet, and this is what pallet operated valve is. And now coming to pallet operated check valve. So a simple check valves allow flow in only one direction, right? But a pallet operated check valves add an important feature. It's allow the free flow in one direction, but it's allow the flow in block direction as well, but only when a pallet pressure signal is applied. This pallet pressure lifts the poppet against the spring force and allow the oil to pass in that direction. So its behavior becomes free flow in one direction and block the flow in opposite direction, but that blocked flow opens when pallet signal applied. And now let's see how we use this valve in real hydraulic circuit. But before that, I want to mention something very important. In industry, I have clearly seen there is a kind of a stigma around the mechanical engineers. That is, we are only good at mechanical things. And when it comes to electrical circuit, logic or programming, that is considered outside of our domain. And most of us easily accept it. But in real machine design, this is not true. Because when we are designing a complete system, we also need to understand the control logic and overall system behavior. And this is exactly why I use Brilliant. Recently, I went through their electrical and digital circuit course. And what I like is you are not just studying the theory, you are actually interacting with the circuit. You connect the components, change the input, and instantly see how the system behaves. It almost feels like solving a real world problem rather than memorizing the things. And because of that, you actually start building real understanding, not just memory. Out of curiosity, I also started exploring their Python exercises. And the same thing applies here. You don't feel like you memorizing the syntax. You are building a logical and problem-solving ability. And it's not limited to circuit and coding. If you want to understand mathematics, AI concepts, scientific thinking, everything is available in one place. Brilliant is designed to help you reach serious learning goals, and platform adapts your level. So whether you are just starting or already experienced, it adjusts the difficulty and build your understanding step by step. So if you want to improve your foundation and problem solving ability, check out Brilliant. Go to brilliant.org/master mechanical design, or you can scan the QR code on the screen. With a premium subscription, you get unlimited daily access to all courses. And if you sign up with my link, you will get 30 days free plus 20% off annual subscription. And now back to the topic. So let's say we have a heavy hydraulic press of around 50 tons and the cylinder is mounted vertically with a heavy ram and tooling, around 2 tons of the load. And to operate this cylinder, we are using 4x3 Tandem center spool valve. So to move the cylinder down, we activate the right side solenoid, the spool shifts and cylinder moves down to perform the pressing application. Now to move the cylinder up, we activate the left side solenoid, the spool shifts to the opposite side and the cylinder moves up. And now let's say the operator is unloading the pressed component. So in between, we shouldn't keep the solenoid turned on because the cylinder is already retracted. If we will keep the solenoid turned on, the system pressure will be maintained to relieve valve pressure. Means the pump will operate at maximum pressure. That will keep consuming higher electricity and also the oil will get heated. So we will have to put the solenoid in neutral position. Now you can also say, why not just turn off the pump and also the machine? So in that case also, none of solenoid will be activated, so valve will shift in neutral position. Now third case can be, let's say cylinder is operating, but the operator put their hand accidentally. In that case, we want the cylinder to stop immediately and hold its position safely. So again, we need to put the valve in neutral position. And this is why in vertical press machines, we had choose tandem center valve. Here in neutral position, P is connected to T, so the pump is unloaded, and the cylinder ports A and B are blocked, so cylinder stops. But as we have learned, the spool valves have internal leakage. So due to internal leakage in spool valve, the cylinder cannot hold its position perfectly. Over the time, the cylinder will creep and fall. So to solve this problem, we add pallet-operated check valves on cylinder ports. Now, oil can flow freely into the cylinder, but oil cannot come out unless check valve receive a pallet signal. And here is the key idea. We connect the pallet lines of each check valve to the opposite cylinder ports. And now understand it carefully. To extend the cylinder, when the valve connects P to A, oil flows in cylinder through check valve 1. And at the same time, the pressure is sent to the pallet of check valve 2. This pallet pressure opens the check valve 2. So the oil from the rod side of cylinder returns back to the tank. So the cylinder extends without any issue. Now to retract the cylinder, when valves connect P to B, oil flows into the cylinder through the check valve 2. And at the same time, the pressure goes in pallet of check valve 1. So check valve 1 opens, and the oil from the piston side of cylinder returns to the tank. So the cylinder retracts normally. And now the critical part. To stop the cylinder at any position, we shift the valve to neutral position. So there is no pressure going to port A and B. So also no pallet signal is available at either check valve. As a result, both pallet operated check valves remains closed, and the oil gets trapped inside the cylinder, and the cylinder cannot move at all, even under heavy load. And this is how we completely eliminate the creep problem of the cylinder. Now, in many cases, we don't need check valves at the both ports. For example, in vertical press, the main concern is preventing downward movement. So we can use a single pallet operated check valves on the load holding side. Another thing, instead of complex hose routing of pallet operated check valve, we can use modular pallet operated check valve block. These are compact unit with both check valves integrated, and directional control valve can mount it directly on top, and they provide same function with much cleaner and more reliable installation. Now, everything looks correct, but there is still a practical issue. If we use a tandem center or closed center, in neutral position, the cylinder ports are blocked. So the oil gets trapped in the line above the valve. This trapped oil can create residual pressure, which may slightly disturb the pallet line and cause vibration and instability under load. So to avoid this, we prefer to drain these lines properly. Doing so, one way is used a 4x3 float center valve. In float center, the port A and B are connected to the tank. So any trapped oil is released back to the tank. This keeps the system more stable. But again, it's keep the pump loaded as pressure port is blocked. So it's depend. If the system has a variable piston pump, we can use the float center because pump can automatically reduce the flow and pressure when neutral position is activated. But if we have a fixed displacement pump like a gear pump, then blocking the pressure port will load the pump. So in that case, we may prefer an open center valve where all the ports are connected and pump flows go directly to the tank. But here is also we need to be careful. If the valve is not properly sized or the flow is too high, some unwanted pressure can still reach to the cylinder ports. So as far as fixed pump loading is the concern, we have practical option. Is continue using a 4x3 float center valve and use a solenoid-operated pressure relief valve for unloading the pump. This type of relief valve can perform multiple functions depending on how it's configured. First, it works like a normal relief valve. It limits the system pressure to a set value. Second, it can also use to unload the system completely by directing the pump flow directly back to the tank, reduce the system pressure nearly zero. So we can control this relief valve in such a way that when directional control valve shifts to neutral position, the solenoid of the relief valve is activated and the pressure line open to the tank, so the pump get unloaded, even though we are using a float center with pallet operated check valve. Also, these solenoid-operated relief valves often comes with vent restrictor, which allow the pressure to drop gradually instead of sudden. This helps in reducing pressure shocks in system. We will understand different type of pressure relief valve and their selection in separate video. So as we have seen, there is no single best hydraulic circuit. Everything depends on operation and operating condition. If the system operates at low pressure, no heavy load, and the cylinder creep is not the problem, we can use these directional control valves directly as per the system functional requirement. But if the system operates at higher pressure, like hydraulic press, there are two things. If the pump is variable piston pump, in most of hydraulic presses we use variable piston pump. Then better to go with 4x3 float center with pallet operated check valves. But if the pump is fixed displacement pump like a gear pump, then again go with float center with pallet operated check valve, but also choose one of the method to unload the pump. Solenoid operated pressure relief valve. Now in hydraulic circuit, selecting the right directional control valve is one part. We also need to select the right flow control strategy. And when lowering the heavy load can fall faster due to gravity. This is called runaway problem, which creates cavitation inside the cylinder. To prevent this, we need to use right counterbalance valve. Also, if the pressure is very high, before shifting the directional control valve, we need to decompress the pressure. For that, we use decompression valve. But this video has been so long than expected, so we will cover all these valves in coming video. So make sure you subscribe the channel, and thank you so much for watching this video.